will be able to stream this webinar live. And now I would like to invite the Honourable Minister of Health to give his opening remarks. Thank you, Minister. The Minister is just still connecting his audio, and he will be with us shortly. It seems that there is a bit of a technical glitch. Thank you, Minister. It looks like you have your audio. Thank you.
Thank you very much. I'm sorry. Can you hear me? Am I audible?
Yes, Minister, we can see and we can hear you. Thank you very much, Minister.
I'm sorry. I had a bit of an issue here, but it's sorted. Thank you very much. Let me then start my greetings to the Deputy Minister, Honorable Dr. Joe Pahla, the co-chair of the Ministerial Advisory Committee, Professor Abdul Karim, the Director General, Dr. Sandile Buthelezi, the scientific team that will be presenting tonight. Professor Karim will introduce them shortly, colleagues and healthcare workers and colleagues in the whole health sector, members of the media and members of the public. It does give me a great pleasure to open this webinar on advancement in COVID-19 research. We particularly focus on the 501.V2 variant and the implication it has on the epidemiology of the South African pandemic. Previously, we postulated that this variant may be driving the increased transmission observed in the second wave. We also stated that more work needed to be done to ascertain the virulence and ability to evade our defense mechanism, including therapeutics and vaccines. These theories have been scientifically tested, and we therefore come together with the scientific and research community to gain some insight into this work and the current observations that have significant bearing on the way we need to respond to the variant and future mutations. As a country that carries 85% of the SADC region burden, it is incumbent upon us to take the leadership in strategies for combating COVID-19. The work that has been done by the scientific community, especially in the field of genomic surveillance, has been exemplary, and I wish to take this opportunity to thank these colleagues for positioning the country as a world leader in genomic surveillance and emergency response. We are very proud of the fact that we are dealing here with research that comes from South Africans to solve a problem that South Africa is facing. It's got implications for the whole world, but certainly in this regard, we are happy that our team is actually on the leading edge on this technology, cooperating with various other countries. We are actually going to be getting the best solutions, the best findings, the best research outcomes like any other part of the world. It has been encouraging to know that despite the mutations, we're still able to protect ourselves with the armor that we've established. This week has seen some promising signs of decline in transmission. Yesterday, we noted a 23% decrease in new cases nationally compared to 7 days prior. This could be attributable to many factors, including enhanced physical distancing facilitated by lockdown regulations. We must thank the South Africans for adhering to all these regulations. Difficult and as frustrating as it may have been, every sacrifice made has saved lives, and we appreciate the patriotism South Africans have displayed to protect the sanctity of life. When we look at our records at this point, we can see that we are possibly beginning an inflection of the curve, and we are also seeing that the numbers may well be starting to decline, but that is too early to celebrate. We must say, we think that what it shows is that there is already an impact of the use of masks, hand sanitizers, the distancing, and all the other restrictions that have been put in place. They're beginning to bear fruit. So we need to persevere and continue with those, because they are just as effective in this wave as they were in the first wave. And therefore, it's important for us to say we must keep on these containment measures. But nevertheless, we must also know there are new issues that need to be confronted with this new variant. But despite all that, we use the same armament to deal with it and defeat it as we did on the earlier wave. Having said that, the healthcare system continues to experience significant strain, with hospitalization continuing to trend upwards, showing an 18.3% increase on the 16th of January to 7 days prior. As 16th of January, nearly 18,000 patients were admitted, with 2,472 in ICU, 1,117 on ventilators, 5,850 requiring oxygen. This is a significant additional burden to the system, and we must salute our healthcare workers for their stamina and courage as they continue to battle it out in the forefront. We understand the significant risk that you as health workers take every day, yet we have witnessed sheer commitment by the professions in healthcare and the willingness to engage in pursuit of excellence in the healthcare service delivery. We thank you and appreciate your work, your dedication, your devotion during this very extraordinary time. This session, therefore, is for you, the frontline workers, who must individualize each patient care with the tools given to them. We hope that this session will allow us to bring the best solutions in case management to the fore as we elicit, as well as elicit some public health considerations that can take us forward in the fight against COVID-19. I therefore want to assure you all, no matter what debates and speculation there may be out there in the environment, that this government will provide you with the vaccines. The program will prioritize you, health workers, as our frontline workers from the first quarter of this year. We will then continue to roll out the inoculation to all the different parts of our country during the second quarter onwards. Today, I give you this undertaking, and we will not renege on this commitment. It finally remains for me to make a heartfelt appeal to the nation on behalf of my colleagues who stoically remain committed despite being exhausted by the sheer burden of the COVID-19 pandemic, as we move back to our places of work and as even we prepare for mass inoculation. We must continue to adhere to the regulations, to the containment measures, the use of masks, distancing, hand washing, hand sanitizing, and all of those will remain very, very important. It will be crucial, this will be crucial to ensure that we can maintain a decline as we're observing now, which will be threatened by increased movement of people across the provinces and into places of congregation. Everyone must continue to play their part and protect one another. Without further ado, therefore, I'd like to declare this webinar open and look forward to discussions that will ensure this evening. I therefore want to hand back to Professor Abdul Karim to lead the team of scientists who are going to open to us what they've been finding. And these are ongoing conversations that will make sure that we are always led by the innovations and findings based on science and research, so that whatever decisions we take are guided in a manner that will always work for the best interest of the public. Thank you very much, Professor Abdul Karim. I hand over to you. Thank you.
Thank you very much, Minister. Thank you very much, Dr. Manzi. It's indeed a pleasure and an honor to have this opportunity to share with our clinical colleagues, academics, and the media and the lay public with some of the most recent findings that we have on the new variant that was first described by us on the 18th of December. Since then, it's almost a month, and we've learned a lot more. So today is an update on that information, and we will be hearing from 8 of South Africa's finest scientists and clinician scientists, among them being Professor Penny Moore, Professor Tullio de Oliveira, Professor Willem Hanekom, Professor Alex Segal, Professor Koleka Melisana, Professor Marianne Davies, Dr. Wasila Jassett, and Dr. Richard Lessels. Between them, they will be sharing with you some original data, some data that they have gleaned from all of their readings. What we want to give you in the course of today, in this session, our goal is at the end, you will have an understanding of this new 501Y.V2 variant. You will have some understanding of its major implications for our epidemic, and then I will end off with making some concluding remarks. In terms of format, I will do a presentation now. I will then invite each of our panelists to make some short comments, and they will be expanding on items that I have dealt with in the course of my presentation. I will then be inviting and taking questions, and I will direct them to various members of the panel. Before I begin, I would like to ask that we take a moment to remember all of our colleagues, our friends, our neighbors, our community members, and all of those who we know and perhaps don't know who have succumbed to this disease. This has had a devastating impact on us as a people, on us as a country, and on us as a nation. Can I ask that we bow our heads in silent prayer for a few moments? Thank you. It's now my pleasure to give you an update on the COVID-19 epidemic and the 501Y.V2 variant in South Africa. What I am doing is giving you an update from the time we spoke on the 18th of December, where we shared these data with you, and since then, the manuscript has been submitted to a journal. We are expecting it to be published imminently. What we said at that time is that the scientists from CRISP led a consortium of researchers from throughout our country, led by Professor Tullio de Oliveira. What they did was looked at viruses from various parts of our country, did detailed sequencing of that virus, and showed that we now have a new variant. And that variant had 23 mutations, 20 of which led to changes in the protein. It should be pointed out that Professor de Oliveira shares with me every month the gene sequences of the viruses. We've been doing this since April. Every month he comes to see me and I look at the data with him, and we're lucky if we see one, sometimes two mutations. In fact, after about 4 or 5 months, I said to him, do you still want to come and do this? And so you can imagine the surprise we had when we saw in November that now we were seeing 23 mutations in the face of a virus that had been quite stable. And what we have seen is not just that this virus has these mutations, but as you can see from the diagram on the left-hand side, that it has systematically spread. It's been spreading across our entire coastal region. We don't yet have the sequences from the rest of the country, but as soon as we have that, we'll be able to plot how it is spreading throughout our entire country. And what we saw in the yellow is how it quickly came to dominate all of the sequences that we were doing. In our latest data from KwaZulu-Natal, 59 out of the 61 sequences from Professor de Oliveira's lab came up with the new variant. This new variant is now the predominant virus spreading in our midst. So I will attempt to answer 4 key questions. The first, is the 501Y.V2 variant in the second wave spreading faster? I'll share some biological evidence and I'll share some epidemiological evidence. The second is the 501V2 variant more severe? Does it cause more severe clinical illness? The third, is there any new evidence on whether the COVID-19 vaccines are effective or not against this new variant? And I'll end off with, do antibodies from South Africa's first wave in the circulating viruses we had then kill the 501Y.V2 variant in the second wave before making some conclusions and next steps? So let me get directly into the business of the day. So when we look at the overall COVID-19 epidemic in South Africa, this diagram, the black line, the solid black line, is the 7-day moving average of the number of daily cases. You can see how in our first wave, we rose and reached a peak in the middle of July. Subsequently, it came down to a trough. And then as we saw our new variant emerging in the latter part of October and in November, just at the time that the virus started spreading and we went into our second wave. You can see that our second wave reached completely new heights. We are now seeing today more cases and more deaths than we ever on any day saw during the first wave. This rapid rise in cases is also accompanied by the rise in the gray bars, which are hospital admissions. So as we get more cases, we get more admissions. And then in the red line at the bottom, most unfortunately, we see the deaths start rising. So this conglomerate that we are seeing in terms of new cases, increasing admissions and deaths is a telling factor in what we are observing in the second wave. And as the minister pointed out, I will touch on some of the most recent trends, which are still early, but just to note them. So let me start with what kicked off my deepest concerns. It turned out that on Boxing Day, I was going up to watch the cricket match. And because I got there early and the cricket hadn't started, I said, well, I'll just check my emails. And of course I did that, and that was a mistake. Because what comes up is this paper by Fratev. In this paper, as I'm reading it, and I look at the 501 and the 417 mutations, and I see what he found they were doing. Doing studies using free energy perturbation, he showed how these amino acids, which have changed, which lead to changes in the charge and the shape of the protein, he showed how the binding of the virus to the human cell had changed significantly. In particular, what he noted is that the virus and the spike protein now rotates about 20 degrees so that it's able to approach more deeply into the binding site, so that its affinity and its ability to bind to the human cell is now stronger. And that's what enables it to become a more efficient virus in the way it transmits. And we're seeing that. We see it in the number of the proportion of tests that are positive. On the left-hand side is the daily average number of tests that are being performed, and on the right-hand side is the proportion of tests that are positive. You can see we went to a high of almost 32%, almost 1 out of 3 tests being positive, higher than we ever had in the first wave. And now we're slowly starting to see how it's coming down, with last week being at 27%, and this week it's still an incomplete week. We're now seeing closer to 23%. So this drastic change that we're seeing is being driven by a virus that certainly biologically looks like it can attach to human cells more efficiently. And we saw it across the board. This was looking at how the epidemic and how the number of cases from the last week of December to the first week of January and how it changed. The light yellow color refers to a number of cases that are below 10 per 100,000. whereas the mustard color is above 10 but below 15, and red is above 15, which we would consider to be high levels of transmission. And you can see how from the latter part of December to the first week of January, every province has turned red. And the last column shows the increase in the proportion of tests, the number of cases that are occurring on a daily basis. Almost every one of those is positive. And if we look at the entire country, week on week, almost a 1/4 increase in the number of daily cases. If we look at the next week and the way in which it's changed, you can see how we've gone from red and we've still remained at red. But though it looks like some of the earliest epidemics that we saw in the Eastern Cape and the Western Cape are showing some early signs of easing off. But we are still in the throes of the second wave. If we look at it by province, each of these colors represents a different province. And if we look at the way in which they've risen, I will now tease it out individually in the provinces to indicate the impact of the variant and the impact of the second wave. So if we look at the Western Cape to start with, looking at the Western Cape, the light green line is the first wave. I've superimposed on the first wave the second waves to show you the direct comparison. If you look at the way in which the second wave has risen to almost double what the peak of the first wave was, and you can see how it lasted and how we're now starting to see this decline. It's still too early to show, to determine whether it's consistent, but it certainly looks a promising trend. If we look at the impact that that had on daily hospital admissions in the Western Cape, that's indicated in the blue line. If you look at the second wave, the number of daily admissions was more than double than any level during the first wave. So we certainly have been seeing a dramatic difference in the second wave compared to the first. And we know it subjectively, we know it anecdotally, we know it from what's going on in our own families, in our own neighborhood. And now we can see it in terms of the impact it's having overall within the provinces. Now let's go on to the Eastern Cape. In the Eastern Cape, the second wave has been much more substantial than we saw in the first wave. And finally, if I go to KwaZulu-Natal, remember the blue line is the 7-day moving average of admissions. Again, you can see in KwaZulu-Natal, the second wave has far more admissions per day than at any point during the first wave. The second wave has put enormous pressure on our healthcare system. And if we look at KwaZulu-Natal, it's a good indicator of the difference. If one looks at the first wave in KwaZulu-Natal, that's in the light orange line, we would describe that, just to be descriptive, as probably something akin to like a Mount Kilimanjaro. However, let's look at what's happening in the second wave, in the dark orange line. It simply went up, 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 and up, all the way to the equivalent of a Mount Everest compared to Kilimanjaro. That's what we are seeing in the second wave here in KwaZulu-Natal, as we are seeing across the country. Fortunately, we're seeing some of that decline because as we look at the way in which this virus has spread, what we have seen is that it spreads much faster. It's left to be seen whether it will end faster, but certainly it has spread much faster. In this study undertaken by colleagues at the London School, they found that the 501YV2 variant is 50% more transmissible than the previous variants we had in South Africa. This was done with mathematical modeling where they extrapolated what we should have seen in the second wave if we had the same variants and what the difference was. You can look at it another way. How many days did it take to reach 100,000 cases in each of the first and second waves? Well, in the Western Cape, it was 50% faster. It took 107 days to get to 100,000 in the Western Cape in the first wave. but only 54 days in the second wave. In KwaZulu-Natal, it's 39% faster. Took 54 days in the first wave and 33 days in the second wave. Now, this is, of course, needs to be taken into consideration that looking at the rate at which we reach 100,000 cases is influenced by many things, confounding by behavior, testing, reporting, any number of factors, but among them, of course, being the new variant. So, how does the 501YV2 variant compare to the B117 variant, the one that was described a few days before the 501 variant, and that was described by our colleagues in the UK? Well, in this analysis, again from the same group, they looked at the prevalence of the virus, hospital admissions, ICU bed occupancy, and a whole range of different factors. And they calculated that the B117 variant, which has a sole RBD mutation at position 501, is 56% more transmissible than pre-existing variants. Now remember that the B117 variant has only one mutation in the receptor binding domain, just at position 501, whereas the 501YV2 variant that we have circulating in South Africa has 3 mutations in the receptor binding domain at positions 501, 484, and 417. And I'll come back to that in a bit. But interesting, in this study that was undertaken by our colleagues at the London School, they found no evidence that it was causing any more severe disease. So let's go to the next question. So is the 501YV2 variant more severe? The B117 doesn't look so. What do we know about 501YV2? Well, let's look at the data. Again, just looking at the same 100,000 cases, did we see more admissions in the first wave versus the second wave? The answer to that is no. They're pretty similar. If you look at the first 100,000 cases and the proportion that were admitted, they are similar in the first wave and the second wave. So that's a starting point. Again, there are many caveats to interpreting this, as I mentioned earlier. But let's look at the data in a little bit more detail. So if we look at the admission disease profile in the Western Cape, and these are data that come from Professor Marianne Davies, she divided the periods up into the early wave 1, the late wave 1, the between waves, and wave 2. And she put each of them into a different color. So it'll probably just be simpler if you compare the orange bars and the yellow bars. So the orange bars and the yellow bars, in other words, the second and the fourth bars. And you can look at across the board from the first wave and the second wave, because that's where they are, the first wave being on top and the second wave, and you can get some idea of the way in which we are seeing very little change. And she points out that there's really no notable difference in those who are admitted or deceased in terms of the different wave periods. And I'm going to ask her to comment on this a little bit more detail in a bit. She undertook another, even more interesting analysis. She looked at the mortality rate. She looked at the risk of dying and looked at it in the different age groups. Again, she divided it up into those same 4 periods. And if you look across the 4 squares in each age group, if we are seeing a trend towards an increase in the orange, in the yellow, that's right, that depicts the second wave, then we would be concerned. But in fact, when we look at it, it's pretty similar. The level of difference between the different little squares is within the margin of error. And she calculated a probability of death in the public health sector adult cases by 30 days since diagnosis, looking at age and wave period, adjusting for confounding. And what she found was no difference in mortality by age between the waves. So in other words, for each age group, the risk of dying is similar in the first and second wave. And you're going to be hearing directly from her shortly after the end of this presentation. In this analysis, Dr. Wasila Jassett, who works with Dr. Lucille Bloomberg and Dr. Richard Welch, have been collecting data on all admissions to hospitals in South Africa. This analysis, done by Juliet Pullian from SASIMA at Stellenbosch University, looks at the mortality trends by age group. And essentially what you want to look at is how flat are the tops of the bars? Is there any clear upward trend? You will expect some trend because we do expect more people to die when we are going through our peaks. But if you look across the board, whether you take 30 to 39-year-olds, you can see that there's very little difference. So mortality in terms of in-hospital case fatality rates, we're seeing little change across the board. So the current data indicate that the virus is not causing more severe disease and is not, but it is putting huge pressure in hospitals, and we may see in due course an increased deaths just from the lack of hospital beds and the pressure in the healthcare system. But certainly at this stage, and we're going to be hearing that we're not seeing an increase in mortality, and we're going to be hearing more about that from Dr. Jassett herself at the end of this presentation. So let's look now at the overall reported deaths, and these are all deaths. The red line indicates all reported deaths. So anyone dying is reported, and we don't know the cause of death, so it's all causes of death. The blue line is the predicted number. So based on past trends, how many deaths should we expect to see this week? And we can calculate a predicted number. And then we look at how does the actual number differ from the predicted number. And you can see very early on, when we were in our very early stages in levels 4 and 5, the number of actual deaths was well below the predicted deaths. And that's largely an impact of the alcohol and the decrease in motor vehicle accidents because we had fewer cars on the road. So all of that combined to decrease the number of deaths. But as we went into our first wave, as we went into our first peak in the number of cases, so too did the number of overall deaths increase. Now, these data show how, as we went into our trough, the number of recorded deaths were roughly similar to the predicted number. And as we now going into our second wave, we see those numbers going up. And this is all thanks to the hard work and the brilliant work being done by Dr. Debbie Bradshaw at the South African Medical Research Council. So I've so far answered the question about, is this virus spreading faster and is it more severe? The answer is yes, it's spreading faster by about 50%, and no, it's not more severe. Is there any evidence on whether the COVID-19 vaccines are effective or not against this variant? I'm sorry to tell you, not yet. Many scientists across the world are working on this. I'm in direct communication with several of them. We don't yet have an answer. We're expecting an answer pretty soon, and there's much to speculate on this, but we want to see the actual data. It's not yet available. So let me go on to the last question. Do antibodies from South Africa's first wave kill the 501YV2 variant of the second wave? So let me start by just showing you a picture of the virus. So the virus, if you want a descriptive way of capturing it, it's a bit like a ball of wool, and it's got these little things sticking out of it. You can think about it like little mushrooms. And those little mushrooms actually comprise different proteins coming together, and they call spike proteins. So if you look at the bottom left-hand picture, that is what the spike protein looks like. Now, you can't actually see it with the eye. and you can't see it in a microscope. It is so small. It is an ultrastructure, so you can only see it with very complicated kinds of microscopes. But that's more or less its shape when you're looking at it from the front. Now, to make it easier for you to understand it, I borrowed a very interesting anatomical approach to understanding this protein from one of the papers that recently was put up as a preprint. And essentially, they compared to a torso. So I put a picture of a torso so you can look at it and compare. What we're interested in is the left shoulder, the neck, and the right shoulder. And the reason we're interested in those is that is where the virus is able to bind to the human cell. Now, I'm going to do a bit of structural biology here. So, see, my idea is to just give you some basic understanding so you can appreciate how this virus has changed and how it is the reason for much of the changes we are seeing. So as we look at this, the brown areas are called the receptor binding domain. So what you're seeing at the top in the left shoulder, the right shoulder, and in the neck of this protein, what we're looking at is the receptor binding domain. And what we have in this receptor binding domain is we have some changes that have occurred. But it's not the only domain that's important from an immunological point of view, because the way our body responds to this virus, it recognizes the foreign elements. And the two key foreign elements it targets on this protein are the receptor binding domain, which is that brown part, and the N-terminal domain, which is at the back end. So I'm just going to focus for ease on the receptor binding domain, because that's the key area I'm going to focus on. So one of the key changes, mutations that occurred in the left shoulder and neck in a position called 484. Now, the three changes, remember, were 501, 484, and 417. Those three changes combined to change the way this protein functions. In particular, the 484 mutation, that prior to the mutation, the area where the 484 was sitting on the human cell, both were negatively charged. And so they were repelling from each other. So the virus had difficulty sticking properly to the cell. When this mutation occurred, 484 became positively charged, which meant that now the virus has a positive charge compared to the human cell. And so when 484 now goes near a human cell, it's able to attach by positive meeting negative charge. So the binding affinity is higher with the changes that we see, with the mutations we're seeing in 484. And you're going to be hearing from Professor Alex Segal, who has set up a live virus assay, which looks a bit like this, where you can look at how a virus that has a 484 mutation can escape antibodies, and how it is able to escape that and continue to grow, as you see here, between the wild type and the virus that has 484 mutations. So I've tried to give you a quick synopsis of the different mutations and what they've done. In this paper, by our colleagues at the University of Washington in Seattle and the Fred Hutchinson Center, they took different viruses and they showed that the 484 mutation is important and particularly plays a big role in creating immune escape. In other words, in enabling the virus to escape existing immunity. And they showed that in the 9 of the 11 convalescent serum samples, that means people who were infected and recovered and now have a range of antibodies against the virus, that those viruses that have a 484 mutation can escape those antibodies and still cause and still survive despite those antibodies. And you will be hearing from Professor Penny Moore how her study looking at convalescent serum from 44 South Africans infected in the first wave that in those 44 patients, that more than 90% of them showed reduced immunity to the 501YV2 variant. And 48%, almost half, had complete immune escape. And that is what you're going to be hearing shortly from Professor Moore when she describes her research. And then you're going to be hearing, because we know that reinfection is not simply a function of antibodies, because remember, your body has two immune mechanisms: B cells that make antibodies and T cells that have cells that go around gobbling things up and killing them. So we use both parts of our immune system to kill the virus. In these studies, we are focusing on the B cells. We are yet to look at the data from the T cells, so that's still coming. But are we understanding that this escape that we're seeing, is that causing more reinfection? In other words, those who got infected in the first wave, are they now getting reinfected in the second wave? There certainly are a few anecdotal accounts, but those few anecdotal accounts are expected. We expected them in the first wave anyway. Are we seeing a systematic increase in reinfection? Certainly the data at this point do not point in that direction. But we'll hear from Professor Mkhize about the research that's being undertaken and about data we have so far on the question of reinfection. So let me answer the question, because you will be wanting to know why, if this virus has a 484, 417, 501 mutation together with N-terminal domain mutations and is able to escape immunity, aren't we worried that, should we be changing our vaccine approach? In my view, the answer is no, not at this stage, not with the evidence we have at this point. Vaccines that we see with the Pfizer and the Moderna vaccines at 95% efficacy are amongst the most effective vaccines that we have for any disease. If you take, for example, the measles vaccine, this is comparable with that, one of our most successful vaccines. So we're certainly looking at pretty high efficacy vaccines. And they achieve a critically important goal, which is they reduce clinical illness and hospitalization. But there are many unknowns. That'll take a long time for us to resolve and answer fully. Questions like, are these vaccines free of long-term side effects? Do they prevent asymptomatic infection, for example? Do they prevent viral spread from vaccinees? Do they work against the new variants? I could make a longer list of questions if you want. But those questions are not any reason for us to hesitate to use a vaccine that saves lives. But I have to say that the vaccine rollout is not going to be easy or quick. It's a mammoth logistical task that's going to need all hands on deck to vaccinate at least our healthcare workers, our elderly, our patients with comorbidities, amongst others, as soon as we can. That's our challenge, to make a difference. And the evidence I'm presenting to you today on the new variant doesn't change that. So what have we learned about the 501YV2 variant? With some caveats, because some of the data I presented are from preprints and not yet published and peer-reviewed, and some of the data still has some residual confounding. Despite those caveats, let me make some conclusions. The first is, this virus is spreading about 50% faster. And so our second wave is faster than our first wave, at least in South Africa's coastal provinces, where we know this variant to be dominant. The current data suggests the new variant is not more severe, and the published convalescent serum studies suggest that natural antibodies are less effective, with viral escape facilitated by the 484, 501, and N-terminal mutations. But vaccine antibodies are different, and they may or may not be impacted. I will not even attempt to speculate on that matter. I'll wait for the data. And certainly, we have no empiric evidence yet on whether vaccines are effective against this variant. Those studies are well underway. I want to caution that we should stick with calling the variant we have in South Africa the 501YV2 variant the 501YV2 variant, which is its name. Please, let's not call it the South African variant. Just like, we don't want to call the B117 variant the UK variant. There are variants across the world. And even if they're found in one country, we don't even know if that's where they originated from. And they will rapidly spread to many countries. The B117 is now in almost 50 countries. The 501YV2 variant is already available in more than 10 countries. Just like how we objected when the US president called SARS-CoV-2 the China virus, we should not call this variant by its country. We should call it by its name. Let me end off with the very sage words of Pope Francis. In this editorial he published in the New York Times, I'll read it. I quote, "The pandemic has exposed the paradox that while we are more connected, we are also more divided. To come out of this crisis better, we have to recover the knowledge that as a people, we have a shared destination. The pandemic has reminded us that no one is saved alone. What ties us to one another is what is commonly called solidarity. Solidarity is more than acts of generosity, important as they are. It is the call to embrace the reality that we are bound by bonds of reciprocity. I am safe because you are safe. On this solid foundation, we can build a better, different human future." I'm quoting here Pope Francis, the head of the Catholic Church. I would like to briefly introduce next the panelists. We will have the pleasure of listening to Dr. Richard Lessels, who is a senior infectious diseases specialist at CRISP, based here at the University of KwaZulu-Natal. And I can tell you that Dr. Lessels is a clinician scientist of note. His work is just outstanding. And he did, if you remember, one of the most interesting outbreak investigations at St. Augustine's. Next, we'll be hearing from Professor Penny Moore, who is not only an outstanding B-cell immunologist, but she's also the chair of virus host dynamics at WITS, based at the National Institute of Communicable Diseases. I've worked with her for almost 3 decades and know her to just be an ace scientist. Next, we have Professor Alex Segal, who is a virologist at the Africa Health Research Institute and a research group leader at the Max Planck Institute, somebody who certainly shows the seriousness with which science should be taken up and whose passion is just wonderful to watch. Next, we'll have Professor Koleka Mlisana, who is the Executive Manager for Academic Affairs, Research and Quality Assurance at the National Health Laboratory Service. Not only has Professor Mlisana published some of the most highly cited research in South Africa, but she has been undertaking research on acute infection in HIV for many years, involved in some of the most groundbreaking research. We'll next hear from Professor Mary Ann Davies, who is a public health specialist, and she is in charge of epidemiology and surveillance at the Western Cape Department of Health. And she was reminding me that I examined her for her specialist training exams. And I was just recounting, she was a top student, and she's shown what amazing flair she has for epidemiology in her wonderful work on looking at the impact of HIV and TB on COVID. Next, we have Dr. Wasila Jassett, who's a medical doctor and public health medicine specialist as well. And she heads up this amazing facility that we hear about, all the admissions in South Africa, and she heads it up at the National Institute for Communicable Diseases. And she, to me, she epitomizes that youthful energy and always bubbling, ready to take on new challenges. Her excitement is quite something to behold. Next, we'll have Professor Willem Hannekom, who's one of our country's leading TB and vaccines expert, and he leads the Africa Health Research Institute. He's coordinating under the auspices of the Medical Research Council and many of the consortium members, a large group of scientists across our country to answer several of the important questions that are being posed by the new variant. And we'll end off with Professor Tullio de Oliveira, whose long hair should not fool you. That bubbling energy you see and his deep commitment to excellence shines through in almost everything he does. He's the director and the head of an organization called CRISP, just a floor below me at the KwaZulu-Natal Research and Innovation Sequencing Platform at the University of KwaZulu-Natal. So I'm now going to call on each of them, and I'm just going to stop sharing here, to make some comments, and then we will, at the end of their comments, I'm going to give each of them 2.5 minutes, and then we'll open it up for questions, and I will direct the questions to each of them. So we're going to start off with Dr. Richard Lessels. Richard, over to you.
Thank you very much, Professor Abdul Karim, and thank you, Minister, Deputy Minister, DG, and esteemed colleagues. So my job tonight is just to give you a very brief kind of overview of what we mean when we talk about mutations and when we talk about the variant, just to really set the scene for some of the other science that you've heard about and are going to hear more about. So just a reminder that when we talk about mutations, we're talking about a change in the genetic code of the virus. This virus is an RNA virus. And so as the virus passes through from person to person and replicates within each of our bodies, you get errors in the genetic code. And this is what's called a mutation. So it's just a change in the letter within the RNA code. Now, most of these changes are innocuous. They don't lead to any change in the amino acid and no change in any of the virus proteins. But some of them, they change the amino acid and therefore change the protein. And they may be able to change the structure of the protein or the function of one of the virus proteins. And Professor Abdul Karim highlighted that when we first noticed this variant, the 501YV2, there were a number of things that were striking about it in the genetic data. So first of all was just the number of genetic mutations that there were was much greater than the other viruses that we were detecting in the country. The second thing was that most of the mutations were causing a change in the protein. And the third thing was that a large number of the mutations were in the spike protein of the virus. And again, Professor Abdul Karim's highlighted how important the spike protein is, because that's the bit of the virus that latches onto the receptors on our cells inside our body, and that also the antibodies kind of latch on to block from binding to the receptor. So that was what flagged this initially as something that we were concerned about, and what made us report to Professor Abdul Karim, to the minister, to the president, to the WHO and other people, that we were detecting this virus that had these changes that were out of keeping with what we were seeing with the other viruses. And then as we learned more about some of these changes, some of these mutations, we became worried that some of them might have what we call a functional significance. So they might be leading to some change in the behavior of the virus. And by the behavior of the virus, we mean the things that Prof. Abdul Karim has talked about. Maybe that could be leading to the virus being more efficient at spreading from person to person, may be able to evade parts of the immune response that are elicited by infection. So these were the changes that made us concerned and made us want to do all this extra work over the holidays and beyond to really understand what the significance of these mutations are. And that's what my colleagues are going to tell you a little bit more about.
Thank you very much, Dr. Lessels. I'm next going to ask Professor Penny Moore.
Thank you, Thanks for the introduction, though, Slim. You managed to add 10 years to my age inadvertently. I'm going to follow up on what Dr. Lessels has just explained, to explain specifically why we were so concerned about the mutations that the genomics team detected in the spike. And the reason that they were of such concern immediately was that the mutations tend to be along a long string. But when you put them together on those mushrooms that Slim described on the surface of the virus spike, they cluster very much together onto two regions. And those two regions happen to be the two shoulders that you heard about earlier, the RBD, or receptor binding domain, but also a second region, which we haven't spoken about so much today yet, called the N-terminal domain. And the reason these were of such concern to us is that if you look at how our immune systems react to this virus, they specifically recognize those two parts of the mushroom. They're like flags waving at the immune system. And those are the specific focuses of the immune response. And so when we see mutations like this, specifically in those two regions, it's a strong indication that the virus has managed to evade neutralizing antibodies. Neutralizing antibodies are the types of antibodies that stop the virus from being able to infect a cell. And indeed, as Slim mentioned, we do now have very compelling data, both from our labs and from many other labs across the world, to support the fact that these mutations are problematic. In our lab, we have seen in a cohort of nearly 50 individuals that half of them, when you test the blood from people who were infected in the first wave and you ask, do those antibodies in that blood recognize the new virus? We find that in 50% of cases, nearly half of cases, there's no longer any recognition of the new variant. In the other half of those individuals, there is, however, some recognition that remains, although I should add that those are normally people who were incredibly ill, hospitalized, and mounted a very robust response to the virus. But I think it's important to split it into those two groups for two reasons. Although it's clear that we do have a problem in these lab assays in terms of recognition of the new variant, if you have very high antibodies to begin with, there does remain some recognition of the new virus. And that's important as we think about vaccines, because some vaccines elicit very high levels of antibodies and others do not. And so we need to understand, using the same kind of lab assays, whether there is some, and there is recognition of by vaccine elicited rather than infection elicited antibodies. And so that's a key thing. But the other thing I want to finish with is that many of the things you've heard about today in terms of antibody binding and antibody neutralization, and Professor Gall is going to speak more about this, are laboratory assays. They're indicative of a problem, and we're taking it extremely seriously. But one should also recognize that there are limitations to laboratory assays. And so we need to wait and look at clinical data from ongoing clinical trials and from epidemiological evidence. And we need to put all of those parts of the jigsaw puzzle together to really understand how serious the problem of immune evasion is with the new variant and whether or not this will impact vaccines. And as Slim said, for that, we need to wait for the data. Thanks.
Thank you very much, Professor Moore. I'm next going to invite Professor Alex Segal. Professor Segal.
Yeah, thanks, Slim, and for your leadership of this of the response to the virus. So I'm going to just follow on what Penny has said, and that is there are concerns that this virus, the new virus, can evade antibodies that were made to the old virus, and that's important because antibodies are really the strongest defense in most infections against viruses. So if we lose the ability to recognize, that's a problem. Now, it doesn't say that you will not mount an immune response to this virus. It's simply that you will not mount an immune response to the previous variants. And the problem here is that the vaccines were designed to the previous variants. Now, we don't know what's going to happen, and vaccines are very complex and can elicit a lot of different types of immunity. So what results we have now are not indicative that the vaccines will not work. But we do know that we have, well, the world has underestimated this virus. This virus can evolve, it can adapt. And in fact, we grew up the this virus in the lab. We're the first group in the world to be able to grow up the 501Y V2 variant. In fact, it's work by a brilliant PhD student, Sandile Sele, who found how to do it. And the way to do it is we usually outgrow it on monkey cells, but he found you need to actually put human cells first. And perhaps that tells you that this virus is adapting to us. What we found, we're going to be releasing tomorrow kind of in full. In general, we have reasons to be concerned because it seems like the virus has found a way to escape from previous antibodies. And I've been kind of working closely with Penny. But we've been working on live virus, and it seems that the answers with live virus are a little bit worse than what they are with other assays. Perhaps the full virus is a little bit more potent. This work, of course, is ongoing. We don't know what's going to happen, but certainly we should be concerned, and we have to accelerate the research on this.
Thank you very much, Professor Segal. I'd now like to call on Professor Malesana.
Thank you very much, Slim. And thank you to my colleagues who have actually presented very clearly ahead of me. So what I'm going to be looking at is, having looked at some of these concerns, the question that we then are left with is, if there seems to be a likelihood that this virus actually might be escaping from the previous immune responses, then what's happening with reinfections? Now, when we talk about reinfections, what we're basically talking about, we are looking at an individual who gets infected today and then the illness resolves, and then we have given 90 days where the individual would be disease-free or virus-free, and they then get a second infection. So we then had to look to see, are we seeing reinfections in the country in the first place, and then relate that to the variant. Now that we have got this variant, are the reinfections a lot more than we had been seeing during the course of the pandemic? So I think we've already mentioned that if you're looking at reinfections, it is because there has been an inadequate immune response or a short-lived immune response. As a result, when the next bout of infection comes, the individual succumbs to the infection. Or it might actually be because the new variant that is coming in, the body has actually not been stimulated to that immune response, and therefore you would get a reinfection. So what we then looked at was how much reinfections are we seeing in the country? And what we did, we used laboratory data because we've got this wealth of data where we have actually been doing testing. And what the analysis that we did was to look at all the tests that have been coming in for testing up until the 6th of January. And when we were at the 6th of January, we had actually done more than 6.7 million tests, and we had about 1,150,000 cases. And we therefore analyzed to see, are there any individuals who had a positive test and then a second positive test 90 days or more later? And the analysis that we had is that as of the 6th of January, with this analysis, we had more than 4,000 potential reinfections, which therefore says to us, we are getting reinfections. And this actually confirms the data that we already know, that we do have reinfections. What we don't know is who actually gets reinfections, what drives the reinfections. And these are some of the, tonight is some of the trying to understand why we're getting reinfections. Might it be because of the new variant or not? Now, the second question was the reinfections. are these increasing with the new variant? When we analyze the data, and up to today, up to the 6th of January, we really have seen a constant risk of reinfections, which means we have not seen a marked increase except for the numbers that we have been seeing, as eloquently mentioned by Slim. Apart from the increased numbers of infections, we are not necessarily seeing an increase in the risk of reinfection. So far, we are able to say there is no evidence that suggests that the risk of infection is increasing as a result of the new variant. But bear in mind, we are only talking a month, so far. So this is an area that we need to look very closely. In fact, we are going to continue to monitor this data and to look to see whether there's any change. If right now we're not seeing any difference, the question is, the minute we see a deviation from this expectation, then we need to look to see, might this be the cause where you're finding that the immune escape by the N501Y-V2 variant is actually causing this, or might it be another emerging variant that's coming in? So thus far, we're not seeing any increase, and there's been a constant risk of reinfections. Now, what do we do then going forward? So because, the numbers that we've been looking at, it really has been retrospective data. So there are studies that are already ongoing. For instance, one of the studies, Professor Qureshi Abdul Karim is currently doing a prospective study, which is actually entitled Incidence of SARS-CoV-2 infections, and she's doing this amongst healthcare workers and populations that are at high risk in the KZN region. We will be able then from this study to look to see how much reinfection are we seeing, and we can then understand better whether those reinfections are increased because of the variant or not. Because right now, we're not able to actually state that. The data is not pointing towards that. And there is also more work that is being done where we want to then look at more clinical work, as Slim has said, where we want to actually look to conduct case reviews of subsets of these reinfections, and then understand a little bit more on clinical outcomes of the reinfections, whether these are the same or there's a difference. And by doing this research, we're going to be able to actually gain more knowledge, and we'll be able to interpret this variant and the impact that it has on the reinfections a lot better. Let me end there. Thank you.
Thank you very much, Professor Malasane. Let me go on next to Professor Marianne Davies. Marianne.
Thank you very much, Professor Karim, for giving us the opportunity on behalf of the Western Cape Department of Health to share what we have seen in terms of trying to investigate whether the new variant may cause more severe disease than the previous variant. And the way that we've done this is to look at all of our known public sector patients in the Western Cape with COVID. And the reason that we stick to our known public sector patients is because these are people that are known well to our services. And so we know about their comorbidities and can take that into account in the analyses. And also we know when they are diagnosed with COVID, we know when they are admitted with COVID, and we know if they succumb to COVID. And we've looked at over 70,000 of these known COVID cases and about 14,000 admissions. Now, we don't know who amongst these people has the new variant and the old variant, but we know that the new variant emerged in the Western Cape around mid-October and November, a little bit earlier in the Garden Route and a little bit later in the Cape Town Metro. So based on the timing of when people are diagnosed, we can compare the second wave and assume that a large proportion of those people had the new variant with the first wave. And in particular, what we focused on is the upsurge of the first and the second waves, where the pressure on health services is likely to be somewhat similar as they cope with an upswing in cases. If the new variant was causing a different spectrum of disease or was more severe, we would expect that there would be a different proportion of admitted people and deceased people with comorbidities, perhaps fewer people with comorbidities, and a different age pattern, perhaps more younger people being admitted or more younger people succumbing to the virus. But what we've actually found is that there's really no difference between the second wave and the first wave. In both waves, about 70 to 80% of people who are admitted have comorbidities, and nearly 90% of those deceased have comorbidities. We've also seen no difference in the age pattern of admitted and deceased patients. We have seen a lot of admissions and a lot of deaths in young people, but that is because we've seen so many admissions and deaths overall. But the proportion of those admissions and deaths that are in young people has remained exactly the same. When we take all of that into account, what we see is that the risk of death, when we take into account age and comorbidities and the number of admissions that hospitals are experiencing, there is no difference in the risk of death between the upsurge of wave 1 and the upsurge of wave 2, which would suggest that this new variant is not causing more severe disease. What is important to note is that both in wave 1 and wave 2, when our hospitals were under severe admission pressure, the risk of death does increase. And that's why it's so important that we lower transmission as much as we can, so that we keep the number of admissions to hospitals low and we flatten that curve, as we've heard so many times, because that really does have a mortality benefit for all our cases, and particularly for those who are admitted. Thanks very much. I'll leave it there.
Thank you very much, Professor Davies. Next, I'm going to call up Dr. Wasila Jasset. Wasila?
Thank you, Prof. And it's an honor to be a part of this panel. So we wanted to understand whether the second wave of COVID-19 was more severe. So we compared in-hospital deaths in the first and second wave. We analyzed data from the DATCOP surveillance system, which receives data on hospitalized COVID-19 cases from 627 public and private hospitals in all 9 provinces in the country. We focused on 3 districts: Nelson Mandela Bay in Eastern Cape, City of Cape Town in Western Cape, and eThekwini in KwaZulu-Natal, as these districts have experienced a second wave for many weeks. Many districts have not completed the second wave, so we compared the early part of the first and second waves from the start until the peak, as Mary Ann has described. So there are 5 important findings I want to share with you. First, the country is experiencing a large second wave, as Prof showed earlier. In the 3 districts, weekly COVID-19 cases, admissions, and in-hospital deaths in the second wave have far exceeded the numbers in the first wave. For example, the weekly COVID-19 admissions in Nelson Mandela Bay peaked at 495 in the first wave and 700 in the second wave. Second, there has been a faster increase of COVID-19 admissions in the second wave. To get from the start of the wave to an equivalent point in both waves, Nelson Mandela Bay took 9 weeks in the first wave and 5 weeks in the second wave. City of Cape Town took 9 weeks in the first wave and 4 weeks in the second wave, and eThekwini took 6 weeks in the first wave and 4 weeks in the second wave. Third, in weeks with very high levels of admissions, there was increased risk for mortality. 40% higher in Nelson Mandela Metro, 60% higher in eThekwini, and 80% higher in City of Cape Town. So what this is telling us is that the higher mortality of hospitalized patients we are observing at the peaks of the first and second wave likely reflect increasing pressure on the health system. Fourth, and to answer the question we posed, is the second wave more severe? Even though there are more deaths in the second wave, when we adjust for the weekly COVID-19 hospital admissions in the district, there was no difference in in-hospital mortality risk between the early first and second waves in all 3 districts. And fifth, there did not appear to be any consistent difference in age between the first and second wave. So it does not seem to be that more young people have been admitted or died in the second wave. So what does this all mean? The second wave appears to be associated with higher incidence and faster increases in cases and hospitalization. However, it is not associated with increased in-hospital mortality in these 3 large metropolitan districts. We did not have data on the lineage type infecting individuals included in this analysis. As has been shared, it seems that the majority of infections during the second wave in these districts may have been caused by the lineage 501YB2. However, we cannot conclude that these trends are related to the new lineage. To do this, we need studies comparing outcomes of people with and without the new lineage. Secondly, analyses like these have limitations. We compared mortality trends in 2 time periods, but there could be many factors that could change between the time periods, such as the impact of national restrictions, changes in individual preventive behavior, and changes in treatment administration, such as the use of steroids and high-flow oxygen, which have been introduced as proven effective interventions for COVID-19. Also, the second wave is still evolving, so it might be early to make conclusions based on these findings. But whatever conclusions we do reach about the transmissibility and severity of the new lineage, what is abundantly clear is that the second wave has overwhelmed the health system, and we need to ensure that hospital preparedness and good case management during these surges in districts where cases are still rising. Thank you.
Thank you very much, Dr. Jassett. Our next speaker is Professor Willem Hannekom. Over to you, Willem.
Thank you very much, Slim. So I wanted to mention that this is actually an effort that's going on nationally, that there have been many researchers from the Western Cape, from Johannesburg, from even other areas of the country that are now meeting regularly. In fact, 40 researchers that have decided if we can come together and we work synergistically on these questions, we can answer the questions much more easily. For example, Professor Lusama mentioned one cohort that looks at reinfection, but there are also 2 other cohorts, one in Cape Town, one in Johannesburg, that's looking at the same question. So if we work together, we may be able to answer the questions more efficiently. So this is really undescribed by the Department of Science and Innovation, and also by the South African Medical Research Council, who was given funding for all this research to go on. So many of the questions that we think are priority questions have already been mentioned in the presentations earlier, but there may also be other questions. For example, if the virus has changed in those little areas that have been shown, will the diagnostics still work? Will the tests that we use to actually diagnose that you have the infection, will they work? At the moment, it looks as if they will work, but we have to answer this question systematically. And of course, as everyone has mentioned here, and there's been lots of questions about this in the chat box, the million-dollar questions about vaccines. And so I just want to amplify what previous speakers have said. Our immune systems are extraordinarily clever. So although there may be small changes in the virus, and therefore the antibodies may not be binding as well, there may be compensation through other arms of the immune system that allow the vaccines to still work. So someone in the chat box wrote, should we not hold off on the vaccines, therefore, until we know more about this virus? And I would say absolutely not. If I could get the vaccine today, I would take the vaccine today. And so I'm extraordinarily enthused by Minister Mkhize and their efforts at the moment to acquire these vaccines so that we can get South Africans vaccinated. So getting the vaccine in people's arms may even be more important, I think, than answering all these research questions. So thank you, Sim.
Thank you very much, Professor Hannekom. It remains for me to invite our last speaker on the panel, Professor Tulio de Oliveira, to address you. Tulio, the floor is yours.
Yeah, thanks, Slim, and thank you very much for this invitation. Yeah, I'd like also to thank our Deputy General of Health, Sandile Buthelezi, and also our Minister of Health, Mkhize. May I just ask to allow my video? Yes, so you don't talk to a black screen. Yeah. So yeah, in my 2 minutes, yeah, I just would like to highlight what it come with that discovery, given that we led a lot of the discovery, and what we want to highlight it is 2 positives that such a discovery, but also negatives from such a discovery. Yeah, the first big positive for this big discovery, that's this new variant that's much more transmissible, it was highlighted by the words of the Director General of the World Health Organization. You need to know your enemy so you can fight that well. So it's very important to know, even if our enemy is a much more transmissible virus. Yeah. The second positive that come with such a discovery, yeah, it comes from the words, for example, of our, both from our Minister of Health, as well as Mkhize, that start today mentioning that South Africa is seen now as a leading group in the world, or country in the world on this genomic surveillance. But also important word from Blade Nzimani, our Minister of Higher Education and Science and Innovation, highlighting that this kind of discovery in South Africa was done faster than anywhere else in the world. Yeah, not only we could discover this variant within weeks of getting the first sample that we could identify a very unusual cluster, but the way that we react to that, you may be not aware, but was through our work with both our national government, the Africa CDC, or the World Health Organization, that end up other countries in the world, such as the UK, to identify their own variant, was our main kind of tip on looking for the mutations. And not that we are better scientists than them, is that we also follow a strong tip from our clinicians that are seeing a very fast increase of cases in the Eastern Cape. And this collaboration between clinicians and scientists is very important to act quick, okay? So that is some of the very positive things about this discovery, which has been highlighted like in the front page of the New York Times, which you are making time now to be on TV. Yeah? What's the negatives, yeah? I promise that was not easy when both Professor Salim Abdulkarim, the health minister, as well as Mkhize, myself and Richard, had to go and present that for our president, Ramaphosa. How do you say to your president that now you have discovered a much faster variant that is gonna completely overwhelm your health system within weeks? That was not easy. What was also not easy was not easy to be like have to defend both in the media, but also to press release attacks from other health ministers in the world about and try to say that we have the worst variant in the world, when our main objective was to be very transparent and do very high level science. Was also not easy when people start associating which the country name, South Africa, with the variant, as Professor Salim Abdulkarim highlight. This variant could have emerged somewhere. And if we didn't have a very detailed genomic surveillance, we could not identify it. What worries us more about at the moment? Yeah, it's two main things. The first is that as we see the decrease on peak, we go back to be complacent. If we are complacent and we cannot stop completely transmission of this virus, we are likely to see a third or fourth wave, and I would not be surprised with more virus that are better adapted for transmission and evade the immune response. Other thing that we are very worried, it is what's happening in our neighboring countries, in the SADC region. And it's very important that we are working through the African Union and the Africa CDC to also support them with both genomic surveillance, but also to increase the access to hospital beds and oxygens, because a lot of our neighboring countries, they have much less resource than us. So thank you again for this opportunity, Professor Salim Karim and our health minister, and I look forward for more questions.
Thank you very much, Professor de Oliveira. Okay, I'm going to now go in rapid fire to get some questions answered. And I've tried to read the questions in the Q&A and some of the questions in the chat. And I've sort of tried to collate some of them together. So my first question is actually a conglomerate of several questions, which is, are our current diagnostics adequate to identify this variant and future variants? And do we need to change any of our diagnostics, our treatments, or our prevention? And specifically in prevention, do we need to change our isolation period or quarantine period that we currently have because of the new variant? I'm going to ask Dr. Richard Lessels if he could please answer that question. Dr. Lessels.
Certainly. So certainly at the moment, there's nothing that's concerning us about the diagnostic tests. We know that the PCR tests are working well to detect this variant because that's how we get the information about the variant, and the sequence information is from the routine PCR samples. And none of the mutations are at sites that make us believe it would interfere with the PCR assay. Similarly, the antigen tests actually look for not the spike protein, but a different protein of the virus. And that's an area where we don't see many mutations. So we expect that, again, the antigen tests should be working well against this variant. In terms of the question of, I think the other question was about the isolation period and things. And at the moment, there's nothing, no information we have that tells us that we need to change these guidelines about isolation period or quarantine if you've been in contact with this virus. There's more work needing to be done to understand at finer detail, the kind of clinical disease that we see with this variant. But we're not seeing anything clearly that suggests we need to change any of the public health guidance.
Thank you very much, Dr. Lessels. The next question I'm going to direct to Professor Mary Ann Davies. There's a question relating to children. Are children more vulnerable to this variant? And are we seeing more severe disease in younger children? Are we seeing more infections in younger children? What do we know about this new variant in relation to younger children? Well, adolescents and children.
Thanks very much. The results that I shared earlier were looking at our adult patients above the ages of 20. We have also looked in COVID cases under the age of 20, and we really haven't seen any evidence of increased risk of more severe disease or any change in the age patterns. It's very difficult to look at mortality as an outcome in children because it's such a rare outcome. So when we look in our analyses for these kinds of epidemiological analyses, you do need quite a large number of outcomes to be able to draw robust conclusions. But if we look at the risk of admission and mortality, so admissions and deaths in children, we really don't see any increase in risk of admissions and deaths combined in our second wave compared to our first wave, using the same kind of approach. And similarly, we don't see big differences in the age profile or big differences in the proportion with comorbidities. And we still see that in the very small number of children who have unfortunately passed on and succumbed to COVID, that a large proportion of them do have a comorbid condition, and that remains the same throughout the two waves of the epidemic. Thank you.
Thank you very much, Professor Davies. Next question I'm going to direct to Dr. Jassett. It seems a contradiction when you say that the virus is more infectious, but not more virulent. That's a contradiction in terms. Is that a real contradiction, or can you explain what we mean when we say the virus is more infectious or more transmissible as opposed to more virulent or more pathogenic?
Thanks, Prof. I think that what we see in the evidence is that transmissibility relates to how quickly the spread is from person to person, whereas virulence and pathogenicity relates to how the severe disease progresses in the people who are infected. And I think some of the data we tried to share today showed that, certainly there is indication that this is a bigger wave, more people have been affected, more people have died, the admissions and cases have spread faster, and so it's quite likely that, it's more transmissible. The new lineage is more transmissible in the second wave, and that echoes the data that's being found in modeling and laboratory tests as well. And whereas in terms of the pathogenicity and the severity of disease, at the moment, the evidence does not suggest that it is associated with more mortality or more severe disease.
Thank you very much, Dr. Jassett. Next question, I'm going to ask Dr. Mlisana. There are several questions about reinfection. Do we have a standard definition? What is it we can learn from reinfection plasma that might guide us to better deal with variants? And given that there's a British study that has already tried to estimate the breakthrough rate in those who've been previously infected, would that approach be helpful in fast-tracking South African estimates? Professor Mlisana.
Thank you, Slim. The standard definition, yes, there now is a standard definition, which is what I actually explained, that we're looking at anybody who gets infected the second time after 90 days. So that is a standard, international definition of reinfections. And I think, insofar as the issue of looking at plasma, that is where we're going to actually get a better understanding. As we have already, suggested by various panelists, that it's important for us to get clearer, understanding of what this convalescent sera actually does. Is it able to neutralize, if we're looking at neutralization, as Penny has said, the fact that we seem to be getting less neutralization, not as efficient as before, but then the question, as Slim had already explained, is that when we're looking at what happens within the human being, it is not just looking at the antibody responses and therefore neutralization effect, but you also have got other, like the T-cell dependent immunity. What is the impact of that? So, but I think especially now with vaccines going on, we will see, breakthrough infections. And it's going to be important for us to look at those very closely and get a better understanding so that we then can take that information and interpret it with the new variant. Bearing in mind, in fact, there was another question, Slim, that I saw that, how sure are we that we're not going to see a new variant in the next 3 months? The truth of the matter is that we do not know that. But what we want to do is to capitalize on whatever information we can gather with this first variant. And hopefully, by the time the next one comes, we will be more equipped and we'll be able to understand it better. And let me just end there. Thank you.
Thank you very much, Professor Mlisana. There were a whole range of questions relating to the mutations. I'm going to ask Professor Tullio de Oliveira to answer some of them. So the questions relate to why do these mutations occur? Is there immune pressure? Are we expecting many more variants to emerge? And I think those sort of summarize about 7 or 8 of the questions that have come together. You basically give us some impression from your understanding of the mutation rate and what can we look to in the future and why would those changes occur?
Okay, thank you. Yeah, that's a very important question, or a number of questions which we are debating a lot with some of the top scientists in the world. Yeah. So the first question, how these mutations arise, okay? So up to 2-3 weeks ago, the main strong hypothesis that would be immunocompromised patients, such as someone, for example, in long-term cancer therapy, that could have a weaker immune system, so wouldn't be able to destroy the virus, and then the virus would escape to that and then be transmitted. And that's the one that we highlight in our results, and that was also highlighted when the B117 variant was identified in Southeast London. Yeah. However, in the last week, it appeared also another very strong potential hypothesis, yeah, when they identify the new variant in Manaus in the Amazon in Brazil. And one thing that the scientific community begin to look, that the 3 areas that these 3 new variants have been identified, like London, the Eastern Cape, and Manaus in Brazil, were also some of the areas that was heavily affected by the first wave. And then the new strong hypothesis came that if you had a high attack rate, what it means, a lot of people became infected in the first wave, and then a lot of people would have decreasing antibodies, as Professor Molasana say, after 90 days, you decrease the antibodies, and then as the new virus coming, the antibodies are not stronger to kill the virus, so it would develop the mutations and spread in the population. So it's the 2 strong international hypotheses, both associated with either individual or population about not be able to suppress the new virus. Yeah. In relationship, will a lot of variants be discovered around the world? Yes, we do expect that. That's something that we led in South Africa by the detection of our variant, which give the UK the chance to detect the one. And we are expecting around the world, as people increase genomic surveillance, that multiple variants will be discovered. And that's especially going to be in places that have a high number of infections for a long time. Yeah. And then the third and the short answer, yeah, will that happen again and again, not only in geographic regions? And unfortunately, the answer will be yes, unless we can suppress transmission to almost 0. Otherwise, this virus will keep outsmarting us. Thank you, Slim.
Thank you very much. Professor De La Vera, before you leave, there was a question about what's the difference between a strain and a variant? I think Elsabe asked that question. Can you answer that, please?
Okay, this is, yeah, the main answer, yeah, is that a lot of times scientists, they want to be precise on the terminology that they use, yeah? So early in the SARS-CoV-2 or the COVID-ID nomenclature, we decided as an international scientific community to call variants, yeah, or lineages. So that's something that would live for a short time and that could be controlled with normal interventions, yeah. A strain normally is used more in bacteria, but sometimes in virus, less often, would be something that has a proven different that keeps spread for a long time. So at the moment, the correct way to call this is called a variant or a lineage, yeah. But that's just a scientific term that scientists like to use more precisely, yeah. But for the general public, I wouldn't worry much about that. Let's just call by the name, not the South African strain, but the 501YV2, yeah.
Thank you very much, Professor De La Vera. I'd now like to ask Professor Moore. There are several questions about your results, in particular what assay you used. And if we're seeing this kind of escape, what does that mean for reinfection? What does it mean for vaccines? And how easy is it to tweak vaccines to cope with the variants that are emerging? I think that's about 5 or 6 questions I've merged into one. Over to you, Professor Moore.
Thanks. So in terms of the assays that people use to measure neutralizing antibodies, there are 2 ways in which this can be done, either using a live virus assay, which is the assay that Alex Segal is running, or using what we call a pseudovirus assay, where essentially it's a way of presenting the mushroom, the spike protein that Slim's told you about, on the surface of a particle. And it enables you to rapidly measure either the full variant or a series of mutations. And that's valuable because it allows you to really drill down and ask questions about whether it's the 417 mutation that you heard about that's causing the problem, or the 484 mutation, or a combination of all of those things. But really the power of these two assays comes from combining that data, and this is why the South African Consortium is relying on both of those assays to inform correlates of protection from both reinfection and vaccination. That data will come in due course. The second series of questions I think are related. What does immune escape, which is what we refer to this as, when we talk about reduced sensitivity of the new variant to antibodies from the first wave, we refer to that as immune escape because the virus has effectively managed to escape from antibodies that were elicited in the first wave. And you've heard a lot already about reinfection. We are concerned that the fact that the new variant shows reduced sensitivity to the antibodies that were elicited in the first wave might mean that there's a higher chance of reinfection occurring with the new variant because it effectively it has a lower bar, so it's able to cross that threshold of protection perhaps more effectively than the old variant. But it's important to, again, we scientists always give you caveats, but it's important to understand also in the context of reinfection, we don't actually have a good sense of how much antibody is enough to protect you. So there is certainly reduced sensitivity. I think there's compelling data from both what we've shown you on this call and from other labs to show there's reduced sensitivity. But we can't tell you that you are now at risk of reinfection at 3 months after the first infection. That kind of hard data doesn't exist. And this is why we keep going back, I think, consistently to the fact that the new variant is as sensitive to the old measures that we used to protect ourselves as the old variants. So we need to continue to use the masks and do the social distancing and sanitize because those tools are as effective against the new variant as they were against the old variant. The question of vaccines is difficult to answer at this stage because, as we've mentioned, we simply don't have the data. We're working very hard, and many scientists are working very hard across the globe. And what we're doing here is we're taking blood from people who enrolled in vaccine trials, and many of you will have done that, enrolled in vaccine trials and received a vaccine. And what we're doing is taking blood from those people who've mounted a response to the vaccine, not to infection. And we're testing those antibodies against the viruses, the new variant, and compare it to the old variant. And that will give us a sense of whether the new variant is less sensitive to the antibodies that various vaccines elicit. But again, lots of caveats, because there are many vaccines that we're testing. They all behave in a different way. They all tickle the immune system to produce antibodies in a different way. So we probably need to look at the sensitivity of the new variant to all of those vaccines. We have those samples in South Africa in our labs, and we're working very hard to answer that question. And then the last question is about how easy it is to tweak vaccines. And where that question comes from is based on the possibility that some of our vaccines may not work as effectively as we had hoped. And the idea is that we might be able to use the same pipelines that we use to so rapidly develop vaccines for this current wave of infections and slightly adjust those vaccines to be able to deal with the new variant. There is potential to do that for some of the viruses, but as Professor D'Oliveira has mentioned, we're consistently dealing, I think, in the future with emerging variants, more and more of these variants. And so we might need to be a little bit cleverer in how we design those vaccines. We might need to look for parts of the spike that are not in those two mushrooms, two shoulders that are so heavily highlighted by the immune system. And we might need to look for other parts of the virus that cannot change so effectively and try to design vaccines to that. But there are lots of ways in which we can do that. We've, as a global community, never moved this fast in developing vaccines. So we can harness all those technologies to tweak vaccines if that's necessary. But the short answer to all my vaccine stories is I agree with Professor Hanekom. If there's a vaccine and it comes my way at the moment, I will take that vaccine. At this stage, we don't have any evidence to suggest that there's a problem.
Thanks very much, Professor Moore. So my next question is to Professor Hanekom. There's a range of questions about diagnostics. Is there a rapid test or a SAPRA-approved PCR test that enables us to distinguish previous variants against new variants? Is there one being developed?
Yeah, very, very important question, because we need to be able to quickly identify if someone is infected with a new variant versus other variants that have appeared before. So yes, the research consortium has a group that looks specifically at diagnostics. And in this group, there is one of their priority questions is to actually develop such a test. So we've identified one specific lab in Johannesburg, which will look at this specifically, and then also working with some companies to try and develop such tests that could be used in broader diagnostic systems that are already available. Thank you, Slim.
Thank you very much, Professor Hanekam. There's a range of questions I'm going to ask Professor Segal to address. They relate to, should we be taking up vaccines if we don't yet know if they are effective against the 501v2 variant? I think we heard Professor Moore and Professor Hanekam's answers to that. The next was, if I can ask you to address, in terms of the variants that have been described in Brazil, do we know, what do we know about those variants? And there's a question here, the Pfizer laboratory in, I think it was Texas, showed that their vaccine is effective against the 501Y variant. What does that mean for the 501Y-V2 variant? So 3 questions. Sorry, Alex, I'm just piecing together questions to give them to you. Can I hand over to you?
Hopefully I remember them. So just a few days ago, my wife's father, he doesn't live in South Africa, he left the country to a place where you can get the vaccine. And I was showing him as fast as possible, because right now there's really no evidence that the vaccine is not going to work. You know, if I had the vaccine, I would take it and encourage people to take it. It's just that there are concerns, and we need to investigate them and understand exactly what this virus is doing. So as far as the third question, which is the Brazilian variant, I don't remember the second one yet, but with the third question, is a very interesting one, because the Brazil variant has similar mutations to the variant. Or the variant found in Brazil has similar mutations to the 501Y-V2 variant found here. And this tells you something about convergent evolution. That means the virus is evolving similar strategies to deal with similar problems, which is antibodies. And this is likely because this is good for the virus and, of course, bad for us. As far as the second question, which I believe was the question about the Pfizer testing their vaccine on the variant found in the UK, it's a different variant. So the one that's found here, the 501Y-V2, has mutations that variant does not have, including the mutation in a place called 484. And that's kind of a big concern. It has also other mutations that the variant found in the UK does not have. So while I would definitely encourage people to take the vaccine, I would not be on doing the research. I would not let our guards down by these kind of studies. This virus is moving. It's evolving, and we need to find out what it is doing. And this is the best way to take countermeasures, is know what you're dealing with, just like Tulio said.
Thank you very much, Professor Segal. Well, it's 3 minutes before the hour, so it just remains for me to wrap up. There are lots of questions. I've tried to gather them as best I could between the multitude of different questions that were asked. But I'd like to just make 3 points in conclusion. The first is that I think what we hear and have seen very clearly is the importance of understanding and appreciating our interdependence. It's not really going to be practical to hope that a country that is vaccinating its population is going to be safe if the rest of the world is not in that position. And the reason for that is very simple. We're seeing that in the course of these variants, that if these variants are developing, they will spread throughout the world. And we've already seen that occur. The first variant that we saw occur was the D614G, which rapidly became the predominant variant across the world. In fact, it was the dominant variant in Europe and became the dominant variant in South Africa. Now we're seeing how the B117 variant, which has the 501 mutation, is now spreading and becoming dominant. And soon we may see 501V2 do the same. So these new variants are going to continue to occur. We heard the importance is just about evolution and natural selection, immune pressure, all of those things bring to bear a change in the virus. The virus has to adapt for its own survival, and it will adapt under those pressures because we're going to see that occur, whether it's from vaccination, natural immunity, all of those will lead to changes in the virus. So it becomes important that we begin to appreciate the importance of all of us at a global level tackling this epidemic and this pandemic as a global community standing together. It's not going to succeed. Our efforts are not going to succeed if we do so in some disjointed way, if we do so in a way that fractures how we want to approach it. So we're hearing that. And I take great heart from the words of Pope Francis and the way he highlights the importance of our interconnectedness. I want to thank the Department of Science and Innovation for all of their wonderful support, for the way in which they have provided funding, support to all of our researchers, and for the way in which the Department of Health, Department of Science and Innovation have made possible much of the research that you have heard in the course of this evening's presentations. I want to pay tribute to all of the frontline healthcare workers who continue to put themselves at risk so that patients may get the best available healthcare, and to put themselves at risk and put their lives at risk so that they can save the lives of others. Finally, I want to say to all of those scientists laboring in their laboratories, laboring in their clinics, poring over mountains of data, as you do that, know that you are now enabling us to be better equipped to fight this virus. That as you join hands with all of us, whether we are clinicians, whether we are nurses, whether we are ambulance men, whether we are any kind of healthcare worker, any kind of scientist, we stand together and pay tribute to all of those who are putting themselves and making themselves available for research. We know that you do so because you have a selfless gift, that you are contributing to research, whether you are a participant or whether you are a scientist in the laboratory. Finally, I want to, making two finallys, I just want to say at the end, a big thank you to the organizers, in particular Wayne Yannicka for organizing this, the computer side of the software, and to Dr. Luazi Manzi for hosting this and organizing this. We have seen how over the years and over the months that have passed, we have seen much in the way of information that is coming out that's not quite accurate on this variant. And so we thought it was important to share this scientific information. For example, there was a headlines and there was an article in the Sunday paper that said this variant doesn't spread faster, it's not more transmissible. There were screaming headlines, we've got herd immunity, our problem is solved with the coronavirus. So we will see in the course of the exercise that we have engaged with to try and bring you the best available evidence, to provide you with the original data as far as we can. And we will see this becoming published and so on, so you will have access to it, that we want to fight disinformation. We want to fight the incorrect and the falsehoods that are being conveyed, sometimes by scientists. So as we fight those falsehoods, as we fight misinformation, we are sharing the truth. And in sharing the truth, we all are beneficiaries. On that note, I thank you very much for joining us for this important discussion, and I'm going to hand over to Dr. Mkhize to close the session.
Well, thank you very, very
All right, that live scientific discussion led by Dr. Mkhize with a number of experts on the new variant 501YV2, just some of the key issues coming out of there. The minister earlier saying that there had been a significant decline in the number of infections, but there's nothing to celebrate at this particular time. In KwaZulu-Natal, more hospital admissions during the second wave than the first wave, indications, some of the graphs showing there how the second wave had much more impact than what we saw during the first wave. We're going to take a short break here on the program. When we get back live to Washington.